All right, so this is something that I've been wanting to cover, and uh, it comes from a bunch of experience with, uh, I don't want to call it overheating, but running hot. So this specifically is my 69 C20, so 67 through 72 Chevy is where this kind of applies to, although it's kind of general good information for cooling systems. So I have a 468 in here. It was running hot, and I discovered a bunch of things, and I learned a lot of things in trying to solve this. Even in working on cars for years, I really had to educate myself on certain things, and so I want to cover that here because a lot of questions come up. I'm on a few different forums, and guys talk about not running a thermostat, not running, if you're talking about a big block, not running a bypass line. I'll explain what that does, and I'll also talk about the Frostbite 155 Radiator and Spall Fans. So first of all, something that I read quite a bit about was, do you run a thermostat or not? And, I figure there's a few things. The engineers put a thermostat in there for a reason. You want it to get hot. You want it to get hot quickly, but then you want it to stay at a controlled temperature. And something really important to remember about thermostats is all they do is they wait to open up. A thermostat's not going to make something run hot. And I don't care what anybody says. That's if it's running hot, you don't have enough capacity in the system, or you're not getting enough flow, or there's something else going on, like a blown head gasket or things like that. Having a thermostat alone will not make you overheat. I don't care how much horsepower you're making. That's not how this works. You got to have some things that are seriously wrong, and it's not to say that. It's not to say that because you're making a lot of horsepower doesn't mean it's not going to run hotter, because it will. There's more energy, but if it becomes real efficient, it's not going to make any difference. If it's inefficient, you have your timing off, things like that. That'll cause temperature issues. So anyways, I won't go too far into that. If more people want information on that, I can elaborate in another video, but this specifically, I want to talk about my cooling system and how well it works, and why it works as well as it does, because hopefully in explaining on why this works as well as it does, people will understand more about how to build their system. So this is like I said, a Frostbite 155. It actually is an interesting aluminum radiator. It doesn't use fat tubes like most aluminum radiators. It doesn't have 1 or 1 1/4 inch tubes in it. Which is interesting. It's built more like a brass radiator. It's got, I think, I want to say 15/16 tubes in it, or 11/16 tubes. They might be that small. I forget. I did measure them at one point. I had a Griffin radiator in this before. It was a 2-core, 1.25 inch tube radiator, and I got rid of it for a few reasons. One of them was it got clogged up, which might have been my fault. There may have been some crap that was still on the block. Who knows? I had a few things apart on it a few times, and it clogged up, but it didn't clog up because there was really a lot of crap in there. What the issue was with the Griffin is they don't weld the tubes to the tanks. They are the tubes where they're flat are, I'll try and kind of describe it. They compress the tube by squeezing it where it's almost kind of crimped inside the tank, and then they fill that with epoxy. So the epoxy starts to leak over time, and B, when they crimp that, it actually reduces the amount of clearance that's in the end of the tube, which restricts the flow a little bit, I think, and B, it gets clogged real easily. So mine had some silicone in it, had a little bit of rust in it, and it was actually blocking the flow. So that's something that you got to really keep an eye out for, is making sure that your core doesn't have a bunch of crap in it, because that'll slow the flow down. That was primarily my issue, but secondarily, something really important to realize about electric fans, and this, by the way, is going to be about electric fans. Clutch fans definitely have their place. I don't have a whole lot of room in here, and B, I don't prefer them because it's hard on the water pump pulley or the bearings. So I try and stay away from them. Electric fans really do work well, and they can be more efficient, especially when you're driving down the freeway. So something important about radiators and fans. When you take a look at a fan rating, especially the Flexolite fans, not that Flexolite doesn't make a good fan, they do. They make good quality stuff. There's a lot of fan companies out there, and they rate their CFM at no static pressure. So that means that, in other words, without going too far into the physics of it, they rate their fans at what their free flow rate is. So no restriction. If you think about a radiator core, it restricts airflow. So there's static pressure there. The typical radiator of this size is probably going to have about a half an inch of water column of static pressure. Think of it as resistance. To pull through resistance, you need torque. With DC motors, larger DC motors have more torque, generally speaking. So these Spall fans are unique in the fact that Spall actually publishes what the curve is, what the torque curve is, or not the torque curve, but what the flow rate is, which is, directly related to the output of the torque on the motor. What the flow rate is with how much static pressure you have. Like I said, there's charts. You can look them up online. I'm not going to rattle it all off here, but in general, it's somewhere between a quarter and a half an inch of water column of static pressure. That you can look that up, and actually, I think I'll post a link in here to a really good article related to this that gives you gives you some of the science behind it. So in short, for just to kind of keep it simple for everyone, you need a fan that can pull the air through a thicker core radiator, especially for us that are running 4-core radiator because we want the capacity. You have to be able to get the airflow. The slimline electric fans, and sometimes you don't have any choice, you got to run one of those. Those motors are smaller. You'll get the RPM, but you won't get the torque. So without that, your CFM rating on the fan is actually going to drop very substantially. So that's why it's really important to get a fan that actually publishes what the rates are. So that way, if you know about how much static pressure your radiator has for airflow, you can get a properly rated fan. And you can look up, there's a lot of information online about how many CFM you need, and some of the information's accurate, some of it's not. My opinion and experience now using these a few times on a few different projects, Spall makes probably one of the better fans. I think the quality is really there, and they publish the data. They give you the performance data, whereas everybody else just says, hey, this is a 3000 CFM fan, and you have no idea anything about what that curve looks like, because with no resistance to the fan, of course it's going to flow 3000 CFM, but one fan that's rated at 3000 CFM may flow 1000 CFM, where the exact same fan, not the exact same fan, but another fan on the exact same radiator may flow 2500 CFM. That's the same size, same diameter fan. But because the motor and blade configuration is different, its flow maintains with the static pressure increase, where the other fan doesn't do that. And so in general, the slimline fans or the thin blade fans are not going to be able to handle the higher static pressure of a thicker radiator, where something with a little bit more torque and a little bit thicker fan, a little bit larger blade is going to. That's not always true, because there is some science there where, some of the newer style or shapes of the blades can accommodate better. So some of the slimmer fans may perform almost as well, but in general, that's kind of the rule. That's about the fans. The shroud, having a shroud is very important. Also having reliefs is also important. I tried it without this in here. I kind of piecemealed this together. I got the fans from Summit. I think I ordered the shroud from a company that's down in, I want to say, San Diego, or I don't know. I found it online. But having a shroud's important. I noticed cruising down the freeway without reliefs in it, I was picking up a little bit of temperature. It wasn't overheating or anything, but cruising down the freeway, it was running about 205, and around town it was running about 195. And it's just when you're cruising down the freeway and you are generating more heat, you need to expel it. And over 30, 35 miles an hour, really, you don't need fans anymore. And so it has nowhere to escape. So these flapper valves seal when you're sitting here and the fan's pulling. And then if the pressure on the front of the fans is higher than at the back, then these flappers will open. I've got one at the top and one at the bottom, which doesn't seem like a lot. They're, 3 inches by 2 inches or so, but it made all the difference in the world. It really runs nice and cool on the freeway now. So I've got air conditioning on this thing. It's got a big transmission cooler in the front over here, and I have no problems with it. It was 95 or 100 degrees the other day. I was driving around the neighborhood a bunch, and it would get up to 197 or wherever I have it set to turn the fans on. It would just drop to 190 right away. I mean, I had the air conditioning on full blast. It had no problems keeping it cool. It's really important to look at the data, to do a little research. If you don't want to believe me, it's fine. This is all my opinion, but I think it's based on science. I think all the mysteries that everybody talks about, removing this bypass hose because some of it bypasses. Some people say it makes it run hotter. I used to kind of believe that, and it probably does because some of your coolant is returning, and this is specific for you big block guys. The thing heats up much faster with this in here, though, and this is what makes the thermostat open. So when you're sitting idling when it's cold and the thermostat's closed, it keeps the pump from cavitating because otherwise you have zero flow with it closed or very little. Some guys drill the thermostat. That kind of does the same thing, but it doesn't heat up as fast. The engineers put this in here for a reason. I believe them, and it doesn't. I don't have any issues with this thing overheating. It doesn't even come close. It did when my Griffin radiator was plugged up, which I flushed the block out real good, and I really didn't get much out of it. I just think I had gotten a little silicone in there from old gaskets and stuff. But I run the bypass line. I've got a 185 degree thermostat in there, and it's perfect. You don't need to run a cooler thermostat. If running a cooler thermostat isn't going to stop you from overheating, it just might start cooling sooner, which is going to mask some other problem that you have. You don't want to do that. It'll just delay it from overheating. That's my opinion. Jumping around a little bit here, but a little bit more on the electric fans. On this setup, I am running variable speed controllers. These are Flexolite controllers. I like these. I've used them a few times now. I've never given me trouble. They're solid state, variable speed. I've got one for each fan. I got one on the other side as well. And the reason why I have two of them is because they're only rated to, I want to say 40 amps, maybe 45 amps. I don't remember exactly. It's right in that neighborhood. More torque means more power. That's in the DC world, more torque means more power. And so these fans easily cruise along at 22, 23 amps. That's just too much for one controller to handle. You can't. I think that Doral might make a fan controller now that can handle that kind of current. But back when I set this up originally, I had a smaller set of fans on it when I didn't know as much and I had some issues. I put a second one on here. I had one on that side where you're looking there already. I added one over here. It's really nice. And the main thing that I really get out of this, other than it having variable speed, is it's much easier on your charging system. There is a massive amount of inrush with electric fans. So it's like having a stalled rotor at first. It means that the motor's not moving at all. It takes a ton of current to get it moving, right? You do that across a relay, it burns the relays, it's hell on your alternator, it's hell on your battery, and it does that cyclically, right? So it's constantly, it cools it off, it warms up, it cools it off, warms up. Every time that relay kicks on, you're using a ton of current, unless you're cruising down the freeway at a pretty good clip and it's back driving the fans, which, by the way, doesn't hurt anything. There's nothing wrong with that. That'll reduce the starting current. But if you're sitting there in traffic and those things are kicking on and off, it's gonna be hell on everything. And eventually it wears out the relay. Relays are electromechanical devices, which means they got a spring in there and a contact. And, without a proper flyback diode, I won't go into too much about what that is. It'll just destroys the relay over time, and they get hot, and it's just not good. These things are solid state, meaning there's no moving parts in them. They have variable output. They're not exactly the cheapest thing in the world. I want to say these are about $120 a pop, but it's the last fan controller you'll ever buy. These particular ones, they do several things. They have an AC input for your compressor, or in my case, I run a trinary switch, which actually activates the fan based on pressure instead of just when your compressor's running. If anybody wants more information about that, ask me, but you don't want to turn your fans on only when your compressor's on, because your pressure is what's important when it comes to air conditioning. But anyways, it's getting sidetracked. These fan controllers have a temperature input as well. They have a manual input as well, so you can tell it to go on 100%. The temperature setting is variable. There's a little screw inside there that you can set it. There's a probe. I run 2 probes on this thing, so the fans actually don't always kick on at the same time. But I have a manual override with my Phytech, and my Phytech can actually kick it on if it gets up to a certain temperature. So we paused there for a minute because 2 gigantic helicopters just flew over. Pretty typical that I'd be shooting a video and that would happen. Anyways, I have my Phytech set up to override and just turn on both fans at 100% if it gets up to, I think, 200 degrees or something. I forget what. I've been slowly kind of inching it up as I got more comfortable with how well this cooling system works. But my fuel injection unit, for those guys that run them, they usually have a control output for the fans based on the temperature input that the fuel injection has. So anyways, I have it set up to do all those things. I got manual override on both these controllers. I've got the temperature probes. About the temperature probes, they're calibrated with that screw, like I said, and you put the probe into the radiator, or they make also a version where it'll screw into the manifold. And what's neat about them is they'll start at 60% speed, and if the temperature keeps rising, and I forget exactly what the math is on it, if it's like, if it raises every 5 degrees, it turns it up 10% or something like that. But it'll slowly ramp up the fan, so you're not drawing as much current on your system. Because if you think about it, we're close to about 45-50 amps with these 2 fans at idle. Which leads me to the last thing that I'll talk about in this excessively long video, is my Mechman Alternator. This is a 170 amp S series alternator. It is pretty freaking amazing. This thing puts out 120 amps dead cold at idle. These are made to order. You can't get them from Summit. You order them directly from Mechman. It's what they call a 6-phase alternator, which I actually kind of laugh at. There's no such thing as 6-phase. It's just the way that it's wound. It has twice the amount of windings in it that you would see in another type of alternator. And that's what gives it the output at the low RPM that it has. It's pretty amazing. I've had two or three different alternators on it since I've had this motor in here. I had a Power Master and it failed. It failed. The case actually failed on it. It actually snapped off down here. Just crappy casting, It died. And I put a March alternator on here because it was suggested by somebody, which is nothing more than a Tough Stuff brand. It's the same thing. And that thing, it was based on the 10SI. It was no good. It put out 120 amps or something at 1,000 crank RPM or something. It wasn't. Today you need output. I got air conditioning, I got fans, had an electric vacuum pump on it, but I've since switched to Hydro Boost. This thing at one point was close to 100 amps at idle. You need the output. You got to be able to charge some too. This thing was putting out 120 amps at idle. And that's what this does. So obviously I've got, I think this is a 4 gauge or a 2 gauge cable I added. I think it's 4. It's good connection, short run. That's always important. But you have to have the correct setup. You got to have matching parts, right? You're gonna use that much current. You got to be able to put it out at idle, because you don't want to be stuck in traffic worrying about whether you're killing your battery or not. So I think that's about it with this setup. So just to summarize, good fans. This isn't an advertisement for Spall. I'm just saying they publish their data. If you want their flow curves, it's available for every model that they sell. The Frostbite Radiator, I'm not so sure that it was, other than replacing my radiator because it was clogged. I will say the Frostbite is high quality. It's aluminum welded all around. The tubes are welded or soldered. However, it wouldn't be soldered because it's aluminum, but they've welded them. Maybe they are soldered. I don't know. Somebody probably knows more than I do, but they're not crimped like the Griffin. The Griffin was crimped. The ends were restricted because of that, and they clogged very easily. If you look inside the tank of this thing, it's got a nice tube that goes all the way across with no restriction in it. This is the 4-core version. Works real well. Soft start or variable speed control, as I mentioned, with these Flex-Lite controllers. I think Doral makes a real high quality unit as well. Good gauge cable too. You have to remember with a 12-volt system, you pull a lot of current because wattage is wattage. Each one of these fans is probably close to 300 watts a pop. At 12 volts or 13 volts, that's a heck of a lot of current. 30 amps is 10 gauge. So, and if it's a long run, if it's a long wire, the longer the wire, the bigger the gauge needs to be. You get a lot of drop. You get a lot of voltage drop real quick with 12 volts. So those are a bunch of really good tips, I think. So run a thermostat. Taking the thermostat out, the whole, when you take it out, you get more flow faster. Well, guess what? You're not taking heat out as fast either. This is a loop. It's not, some folks argue, well, it gets, you can get the cool back faster. Come on, it's physics, guys. You need to be able to remove it at the rate that you can put it back in. So speeding that process up isn't going to change anything, really. You're not heat soaking the coolant as long as you're cooling, and you're not cooling it as long. So taking the thermostat out and increasing the speed of the flow doesn't do anything. That's what I've read. That's what the science says. So if you're running a lower thermostat, don't do that. That's it, you know, and you want it, you know, if you're not running up to 195 degrees, you're not burning off all the moisture and shit that's in the oil. You know, then it builds up, and it does other things. It can cause corrosion and stuff like that because the oil can become acidic. You want to be able to boil off the crap that's in the oil. So you know you want your motor to run at 195 or 200 degrees. So that's a good range right there. If you're running your motor at 160 all the time, it's not getting hot enough. It's not as efficient. The efficiency range for an engine is at that 195 mark. Also with the Frostbite Radiator, I went with these stupid expensive Be Cool mounts because they fit real well, and they were stupid expensive. They're like $200 for a stupid piece of machined aluminum. You know, what the hell? But I couldn't make it myself that nice. I'm sure I'm not that good with a mill, and you know it's just easy enough to get them. They fit. The lower mounts, I used the stock lower mounts. I probably should have changed them, but I put a little rubber insulator. You can't see it down in there, but I put a rubber insulator in the saddle down there to raise it up a little bit. And these fit real well, these Be Cool units. They really fit, unlike the stock ones. The stock ones are a little bit too small. I think that there's a difference between the 4-core and the smaller. I'm not sure if it was a 3-core or a 2-core that would have been originally. This was a camper special, so I think it had a 4-core in it when I got it, but it still didn't fit. So I got these Be Cool mounts, and you know, they fit relatively well. The tank on the Frostbite Radiator doesn't have the ribs on it like other tanks that have pre-formed tanks that are assembled. This is all kind of fabricated as one. You know, the tanks are they're all fabricated instead of pressed. So you know, it's just the assembly is a little bit different, but the mounts fit and it's tight and everything. Anyways, that's an excessively long video on the cooling system tips. This is specifically kind of for you 67 through 72 guys. So this is my 69, but I think it applies to all of them. This is going to be the same. So hopefully this helps you guys out a little bit. And if I said anything in error, you know, I'm sure you guys will promptly correct me. But a lot of this is based on reading I've done and some of my background in engineering. So I've found that the system works very well like this.